Have you ever wondered how astronomers keep their telescopes locked onto distant galaxies, nebula, or planets? In this video, we'll uncover the fascinating science and technology behind tracking deep space objects. There are different methods for achieving the stabilization of deep space objects while using telescopes. Some are manual, using twist screws that move the telescope with a sprocket-type mechanism. Some are separate scopes that are automatic and programmed to do the work for us. And with the Seestar, they are included in the inner mechanisms of the telescope. But before we get too deep into this concept, let's explore some of the basics about tracking and how the Earth's rotation affects the need for tracking. As Earth rotates, stars and other celestial objects appear to drift across the sky. A telescope that is relatively stationary with us on the Earth needs to counteract this movement to stay focused on that object. While all objects in the universe are in motion, we perceive that we are standing still. And so the objects that are moving, they're so far away that they stay in our field of vision and appear as though they're standing still. But they are not. They are in constant motion, just as we are. So as our Earth rotates around, we rotate out of view of the objects that we're trying to image. Most deep space tracking is done with an equatorial mount, designed to align with Earth's axis. Using sidereal tracking, it moves at the same rate as Earth's rotation, but in the opposite direction. This allows telescopes to stay focused on a single object for hours, perfect for astrophotography or long-term observations. In this image, you can see the equatorial mount and how there's a little device hanging off the end that is aligned with the equator of the Earth. As the Earth rotates, there are varying devices that can move the telescope and keep this equatorial mount aligned with the equator. It can be done manually or automatically. This picture shows a manual control for aligning the telescope. This little device hanging off of the telescope, you twist it and it turns a screw, and then it turns the mount. There's a sprocket on it and it turns it. There's usually more than one of these on there so that you can turn it different directions depending on which one. This shows a depiction of someone doing that with that manual control. We used the screw type devices for many years, and they're difficult to align things and be accurate with. So we did finally invest in an automatic one. This is a picture of ours. It attaches to a Celestron telescope and it mounts on there, and then it automatically does the aligning and tracking of the stars. It's got a computer chip in it that matches the stars in the sky and then allows it to find objects and then keep them in the field of vision. Even easier than that device we purchased, which about 10 years ago cost us $300, is the Seestar. It has a tracking programming in its software. It's all combined into this little machine. You don't even see it, but it's in there and it does the tracking automatically for us. Without some kind of star tracking device, whether it be manual or automatic, this is what would happen if you're imaging the stars. Because of the lengthened exposure time, it's not just doing a really quick click, it's keeping the shutter of your camera open for a period of time. This is what would happen if you aren't using a tracking device. Thanks to advanced tracking technology, we can study the wonders of deep space with incredible detail. So, next time you gaze at the stars, remember the tools that make it possible, especially the Seestar S50, which we've been using. It does an incredible job. The most distant galaxy ever observed was over 13 billion light years away, and telescopes tracked it across the sky to capture its light.